Hello and welcome to Mellow Labs. On today's episode, I want to talk about this sensor from DFRobot. It's a Matrix LiDAR distance sensor, and DFRobot did not pay me to make this video, but they did send me 4 of these sensors to play around with completely for free, so my opinion is very biased. It is nevertheless a very interesting sensor I think you should be aware of for your next project. And in today's video, I'm going to go over everything it can and can't do, how to use it, and I myself am going to incorporate it into my 3D printed tank Zippy so he can autonomously ride around my office without me having to control it. And all that right after this message from today's sponsor. Unless of course you're a Patreon supporter, JLCPCB has exactly what you're looking for, whether you're a beginner trying to make your very first PCB or a professional looking for more advanced options. JLCPCB has you covered. Need a simple board just to bring an idea to life? They can do that. Need something a little more serious, like a transparent flexible PCB with aluminum backing and V-ring pad for space saving and an ENIG finish? Well, JLCPCB can handle that too. Getting started is super easy. Just click and drag your Gerber files into jlcpcb.com, select what options you'd like to use, and you get an instant quote. Now I know all of that might sound really expensive, but it really isn't. Because of JLCPCB's large scale, they can bring the savings down to you, and they pretty much always have some kind of deals or coupons going on. Like right now, you can get $30 off of a 6-layer PCB, which brings the starting price down to just $2. And if you're a new user and you click the link in my description, you can get $123 in new user coupons, which makes your first few routing mistakes a lot less painful. JLCPCB does everything in-house with strict quality control at every step, and you can see that progress in your dashboard as you're waiting for your order. And for more complex boards, they'll even x-ray them and send you the images so you can see that everything is placed correctly as it should be. Check out the links in my description, and when you think PCB, think JLCPCB. Easy, affordable, and reliable. Let's start by having a look at what you actually get in the box when you receive it. So we have a baggie with a whole bunch of things inside of it, and in that you get the sensor itself, 4 thumb screws and 2 regular screws, 2 standoffs, 2 metal bracket thingies, and a wire so that you can actually connect it to whatever microcontroller you'd like to use. And when it comes to mounting solutions, I actually think DFRobot did a decent job at giving you as many mounting possibilities as they could. So there are 6 holes to put screws through on the sensor itself, and then the 2 brackets that it comes with are actually made of metal. So I wasn't sure about the bottom piece because it was kind of flimsy, but then I scratched the bottom of it and it's actually shiny. So both these pieces are aluminum, so you can mount this on like whatever robot or car you have, and then angle the sensor so that it can see where it needs to seize. And now let's talk about the stuff on the whiteboard. This is pretty basic stuff really. We've got 3.3 to 5 volts to actually power it, and then to run the whole show it's an RP2040 chip, which is the same chip you have in like your Raspberry Pi Picos and stuff like that. For interface we've got I2C, UART and USB, so pretty much anything you'll ever need. And then for the actual sensor itself, it's a 60-degree field of view time of flight sensor. If you've for some reason never heard of time of flight sensors, they're pretty interesting. They're usually composed of an emitter and a sensor. The emitter will send out a pulse of light to the target, and then it will bounce back into the sensor. And the way we get distance from that is we take the travel time divided by 2, because we only care about it one way, and then we times it by the speed of light, which gives us the distance. And then we run this operation on 64 points on an 8x8 grid, which basically gives us like a 3D representation of what's in front of the sensor. Oh, and also it has a range of 2 centimeters to 3.5 meters. So seeing it on the whiteboard doesn't really do it justice, so I'm going to plug it into my computer, generate some code, and just show you. Okay, so I gave Claude Code a brief description of what I want the program to do, as well as the GitHub repository for this module itself from DFRobot, and after some noodling, poodling, floodling, cloodling, it gave me a Python script, which if I run, it connects to this module because it's on COM port 4, and gives me all the information. I mounted my sensor on top of my water bottle with some blue tack just for some stability, and if I vaguely point it towards myself, you can see an outline of me. And if I move out the way, it goes away, or I can move my hands in front of it, so we have a 3D representation of what's happening in front of the sensor. That's pretty cool. So if I put this on top of like a robot, we'd be able to check our environment and see that there is an obstacle that way and that the path is clear that way. So that's pretty cool. If you have a powerful enough processor, you might be able to like make a 3D representation of the environment. Unfortunately, the robot I'm using it with is Zippy, who does not have a good enough brain. He has an ESP32, which should be good enough for it to like ride around the room without bumping into the walls. So let's open it up, figure out how to mount the sensor inside of it, and get it to communicate with the ESP32. So let's get to work. Okay, I got myself a fresh cup of tea, which means we can start working on Zippy. So if you've never heard of Zippy, this is Zippy. Zippy is one of the first things I've ever made for my YouTube channel, and somehow it still works. It's a fully 3D printed tank with some very basic electronics inside. I have upgraded the electronics a couple times since then. In the beginning it had like a Raspberry Pi and it controlled with a Xbox controller, but since then it's just an ESP32 which talks to another ESP. Well, this is a Raspberry Pi Pico W, but they talk over ESP now and I can move him around. I apologize, on this surface he's very loud, but I will demonstrate. So he can do stuff like that. So now let's take a look inside. And now if I open the cover, you'll notice I've got some 18650s that are running the whole thing. There are some 300 RPM geared motors in there, and I've got my ESP32 here and a motor driver. If you're familiar with these motor drivers, you've probably noticed that I've added a giant heatsink to mine. That's because there's not a lot of airflow in Zippy, so a couple times where I've taken him like out and about to roam the free world, it got a little toasty. So I've just replaced it with a giant hunk of aluminum and I've never had the issue. So now let's go back to the sensor. I want to add this to Zippy as more of a permanent addition, so I'd like it to be inside of Zippy and just like peeking out enough so we can see. And now the problem I'm facing is the motors, you'll notice, are on this side. This is also what I think the front of Zippy is, because I consider these to be at the back. So I don't think I'm actually going to have enough room in here to fit the sensor. In fact, let me take this panel off and I'll find out. One of the things that really drew me to the design of Zippy is how modular it is, because most of the panels you can just take off and like reprint if they need to be adapted. So theoretically, do I have enough space in here to mind my tea to mount that sensor? I think I do. It might have some interference from the motor, but I think that should be manageable. Yeah. I'm gonna go jump into Fusion, remodel this part so that it can accept this sensor. I think the DFRobot has a 3D model or something like that that I can use as a reference and just model that in. Yeah, okay, let's jump into Fusion. Okay, so it's done. It's not the prettiest looking thing. Zippy only exists as STL, so I had to remake the cover all by myself in reference to the STL. I had to print a little test print to make sure I got everything right, and it seems to be okay. Then I had to model the actual sensor itself. DFRobot doesn't provide an STL or anything like that. They do provide all of the dimensions and everything you need to actually model it yourself, so that's nice of them. So I modeled the sensor. I only modeled where the actual sensor head is, nothing else, so hopefully nothing interacts. But yeah, I'm gonna put some heat press inserts into these holes, and then I kind of just smoothed everything else out in order for it to print this way without causing too many issues. So I'm gonna chuck this on the printer, print it out, and then see if it works. To the Prusa Core 1! Okay, it's printed, it looks pretty good. I put the heat press inserts in. Now, does it actually fit onto Zippy? It seems to. It lines up with all the holes it needs to line up with, so that's pretty good. Does the sensor fit inside of it? Kind of. See, I was hoping it would be flush with this standoff. So I can reprint and remodel this, but I don't really feel like doing that, so we're sacrificing the USB-C port. I melted it in the process, so there's no going back for this one. Now it fits perfectly. Let's screw it in. Perfect. Let's hope that this lip isn't actually in the field of view of the sensor. Let's plug in the gravity connector, as DFRobot likes to call it. Wire can go under here, and that can go in there. It actually fits! Wow! Let's screw it in before it decides it no longer wants to fit. Okay, now we should be able to connect it. I'm gonna have to solder this. This is an ESP8266, not an ESP32. I thought this was a 32. Well, hopefully it should still work. What are the chances I accidentally used my I2C pins for something else without realizing? Wow, I did an awful job soldering this. What on earth did I use? Ugh. Ugh. D1 and D2, which by some miracle, no, they're used. I'm at a crossroad. I can either relocate the pins for the motor driver and update the code and then connect the sensor to this ESP8266, or I can update the whole thing to an ESP32, which would give me more processing power. I think this ESP8266 might actually be running MicroPython, because this is back in the day where I used MicroPython on these development boards instead of Arduino, because Arduino is hard. So I'm gonna plug it in and find out. Okay, it's running Arduino. So in that case, I'm gonna give Zippy a very quick ESP32 upgrade, and I'll be back when it's done. Good news, it took a little bit longer than I expected, but both the remote and Zippy are now upgraded. Why did I have to upgrade the remote? Because I thought I was using ESP now between the remote and Zippy, but what was actually happening is I had an access point that would open up when I turned Zippy on, which then the remote would connect to, and that's how they would communicate, which is why it took like 30 seconds from turning both of the things on for them to actually connect, but it's fixed now. I replaced the Pico, I replaced the 8266, they're both running ESP32 now, and they connect immediately. So if I turn on Zippy, it does that now. I think it's a conflicting GPIO issue. I'll fix it in the future. And if I turn the remote on, they connect immediately. It's lovely. And I can now control Zippy. It's still very loud. I still apologize. So now I can actually work on integrating the sensor to the ESP32, which actually conveniently I left myself a connector for. Since I was rebuilding the whole thing, I just added one. So now I can plug this in, and now I can just ask Claude to generate some code that works with the sensor so he can autonomously wander around. Now, in order for me to actually turn on autonomous mode, I think I'm gonna have to make a button combination where if I press all of the buttons, it's gonna go into autonomous mode, because I don't feel like adding another button to the remote right now, because it would involve more work than I want to. So I think pressing all of the buttons is gonna trigger autonomous mode. So I'm gonna go ask Claude to do that for me, and I'll be back in a second. It's been 2 days. We've had some issues. So I started off by giving Claude the script for Zippy and told it to incorporate the sensor. And it did it. I also told it to, do the shortcut of pressing all 4 buttons to engage autonomous mode, which is indicated by the blue LED turning on. And I told it to add a break so that if the controller disconnects, Zippy turns automatic mode off, so that in case it goes back wild, I still have some sense of control. But what would actually happen is Zippy would go into autonomous mode, get all of the readings from the sensor, get overwhelmed with the amount of readings and take a little bit longer to process than ESP now would like, and it would drop the remote. So basically turning off autonomous mode immediately after you turned it on. So that happened through a few revisions, and eventually we fixed it. It worked. It was great. Then I discovered that the cover I designed actually blocks quite a lot of the field of view of the sensor. So here's some footage of the readings without the cover on, and here are the readings with the cover on. So I basically was a little impulsive at this point, grabbed my soldering iron and just carved a big hole for the sensor to see out of. And that seems to have solved the issue. So the sensor now has all of the vision. Fantastic. Then I ran into the problem of having too much data. Because Zippy is quite low to the ground and the sensor is like vertical instead of like at an angle, it sees a lot of the ground. So as soon as you turn on autonomous mode, it's like, the path is blocked. I can't do anything. So I basically had to tell Claude to just ignore the bottom rows of the sensor, which leaves me with 4 rows of 8 columns. So that's still a lot of data. That's dirty. And that kind of fixed the issue of it being constantly blocked, and we started to wander around a little bit more. So I told Claude to implement a sort of spin around feature so that it can check its environment, check how far things are, and then pick the best path. The problem was I didn't tell Claude how fast Zippy is, so it just by default told it to like spin for 3 seconds. Zippy spins very fast. So it would just spin ridiculously quickly, as well as trying to take sensor readings at the same time. The problem is this sensor like takes a second to like get good readings. Not really a second, but you want to keep it still. So basically all of the readings it got while spinning were just garbage. So it would just constantly spin looking for the best way out and never finding it until it crashed into something. So then I told Claude to just dial it down a little bit. Zippy's fast, slow it down, and maybe stop for a second, then take the reading and do that. So it figured it out. We stopped for a second, we took a reading, we turned, we stopped for a second, took a reading, blah, 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 until it found the best path forward. And, you know, we started to get a good automated flow going. Then I found the doorway issue. If you put Zippy in a corridor with an open door, he will constantly spin around trying to find the best way out without realizing the door is open. So because of the field of view of the sensor, it sees the wide open door as well as the sides of the door. So because the sides are closer, it's like, this path is blocked. I can't go this way. So I had to tell Claude to just ignore the sides a little bit. So maybe instead of completely getting rid of these, I would just like fade them out like so. So I told it to just like, as long as the middle is somewhat free, just try your best. So it still checks the sides for collision detection. So if it's heading towards something and it detects that something on the side is getting closer, it will pause and then do a spin to check how far away it is from things. And that's where we are currently. And I think it all works. So now I need to let Zippy loose and just see how well it does. Also, I had to close the door because Zippy doesn't have any kind of downward detection. So if you show it a staircase, it's like, ooh, an open field, and it will try to commit die. So we will test it in a small environment in this room. Get ready for some Zippy footage. It's been stuck in this corner for 3 minutes, trying to figure a way out. Why do you keep going back there? How do I break you out of this cycle? Let me put you in a different area of the room. Stop. I swear to God, if you get stuck in that corner... Why aren't you going forward? Hooray! It's gonna get stuck in the corner again. Hooray, a different area. No, don't you dare. Okay, you know what? I'll take that as a win. I'm gonna stand in this corner so that it doesn't try to go in here again. Why aren't you going straight? There's so much open room here. What on earth could be blocking you? Yeah, I'm done for today. Zippy is not as smart as I would like him to be. Maybe in the future I can get DFRobot to send me one of those actual like spinning LiDAR things and I can give Zippy a bigger brain upgrade. But until then, I'm kind of done with this. It's not the sensor's fault, it's definitely user error. But yeah, check out the sensor. I'll leave it linked down below. Pricing wise, it's going to vary depending on where you are, so check it out yourself. And I guess with that, thank you very much for watching. Don't forget to like and subscribe. Please support me on Patreon if you can, and I'll see you on the next one. Goodbye.